4A1. Calculate the external curved surface area of a cylinder with radius 8 meters and height 19 meters. So if I sketch the cylinder first, with radius 8 meters and height 19 meters, the radius is 8, the height is 19. When it says external curved surface area, it refers to this purple area surrounding the cylinder over here. And if you imagine that you take that curved surface area out and flatten it out, it would be a rectangle. The rectangle would have a height of 19 meters, and the base of the rectangle would be equal to this length over here, the length that goes around the cylinder. So that's basically the circumference of the circle. That means that the base must be equal to 2 pi r. So the area of a rectangle is equal to base times height. The base is equal to 2 pi r, and the height is equal to 19. And we know that r is equal to 8. So the area would equal 2 pi multiplied by 8 multiplied by 19, and that is equal to 955.044. So we have to round this value to 3 significant figures. So that's 955 meters squared. 2. This surface is painted at a cost of $0.85 per square meter. Calculate the cost of painting this surface. So the cost would be the area multiplied by the cost per area, which we know is 0.85 per square meter. So we can write that. And from part 1, we already know that the area of the external curved surface is 955 meters squared. So that's the area. The units also line up because we have the cost per square meter and we have the area in meters squared as well. So we can just multiply it directly. So that's 955 multiplied by $0.85 per meter squared. That is 811.78. So we need to round this to 3 significant figures. So that's 812. B. A solid metal sphere with radius 8 centimeters is melted down and all of the metal is used to make a solid cone with radius 8 and height h centimeters. Show that h is equal to 13.5. So for this problem, when it says that a solid metal sphere is melted down to make a cone, assuming none of the metal is lost, this means that the volume of the sphere is equal to the volume of the cone. And we are given the formula for the volume of a sphere and the volume of a cone from the question. This means that those two must be equal, right? 4 over 3 pi r cubed for the sphere must equal 1 over 3 pi r squared h for the cone. For the sphere, r is equal to 6. And for the cone, radius or r is equal to 8. And we don't know what h is. So if we substitute r equals 6 for the sphere and r equals 8 for the cone, the equation turns into this. And we can use this equation to solve for h because h is the only unknown in there. We have everything else in terms of numbers. So we can solve for h by dividing both sides by 64 pi over 3. So if you do that, h equals 864 pi over 3 divided by 64 pi over 3, and that is equal to 13.5. So that's correct. 2. Calculate the slant height of the cone. So we know that the cone has a radius of 8 centimeters and a height of 13.5. R equals 8 and H equals 13.5. So if you sketch the cone, it looks like this. And the slant height is the length over here. So we want to find that length. And if you take the cross section of the cone, half the cross section, it makes a right angle triangle. So we can use Pythagoras to work out the slant height of the cone. Using a squared plus b squared equals c squared, we can have a squared plus 13.5 squared equals L squared, and we can use this to solve for L, the slant height. So the slant height is equal to square root of 8 squared plus 13.5 squared, and that equals 15.6923 and so on. So we need to round this to 3 significant figures. So that's 15.7 centimeters for the slant height. 3. Calculate the curved surface area of the cone, and it gives us the formula for the curved surface area of the cone, which is equal to pi RL. We have R and we have L from the previous part of the question just now. So area equals pi multiplied by 8 multiplied by 15.7, and that equals 394.391. So we need to round this to 3 significant figures, so that's 394 centimeters squared. C. Two cones are mathematically similar. The total surface area of the smaller cone is 80 centimeters squared. The total surface area of the larger cone is 180 centimeters squared. The volume of the smaller cone is 168 centimeters cubed. Calculate the volume of the larger cone. When it says mathematically similar, it means use scale factors. So if we let x equal the scale factor to turn the smaller cone into the larger cone, we know that for scale factors, when we use scale factors with length, we multiply it with the scale factor once. When we work with area, we multiply by the scale factor squared, and when we work with volume, we multiply by the scale factor cubed. So we are given the surface area of the two cones. This means that the area of the smaller cone multiplied by scale factor squared, because we're working with area, must equal the area of the larger cone. So that's 80 multiplied by x squared equals 180, and we can use this to solve for x or solve for the scale factor. So the scale factor is equal to square root of 180 over 80. So x, or scale factor, equals 3 over 2. So in terms of volume, we know that the volume of the smaller cone multiplied by scale factor cubed, because we're working with volume, must equal volume of the larger cone. We are already given the volume of the smaller cone from the question, that's 168. And we already know the scale factor, x, which is 3 over 2. So that means that 168 multiplied by 3 over 2 cubed must equal the volume of the larger cone, which we are trying to find for this question. So that equals 567 centimeters cubed. D. The diagram shows a pyramid with square base ABCD. DB equals 8 centimeters, P is vertically above the center X of the base, and PX equals 5 centimeters. Calculate the angle between PB and the base ABCD. So when it says that DB is equal to 8 centimeters, this diagonal over here is 8. And when PX is equal to 5 centimeters, this height over here is equal to 5. And we want to find the angle PB between line PB and the base ABCD. So that's this angle over here. So we have a lot of triangles inside this pyramid, and we're trying to find the angle. The triangle is also a right angle triangle, so we can definitely use trigonometry with this. So if we look at triangle PXB over here, it's a right angle triangle like this, where we're trying to find angle PBX. So we have PX, which is 5. We don't have XB, but it says that it's a square base pyramid. ABCD is a square. So if it's a square, that means that X is the midpoint of the square. So XB must be equal to half of DB. So XB equals DB divided by 2. So that's 8 divided by 2 equals 4. So we know that XB is equal to 4 if we label that on the triangle. So for this triangle, if I label that angle X, we have the opposite side and we have the adjacent side. So we can use tan to find the value of X. This means that tan X is equal to opposite over adjacent. So tan X equals 5 divided by 4. 5 is opposite, 4 is adjacent. And then we can find X by doing inverse tan. So X equals inverse tan of 5 over 4, and that equals 51.340, and so on. For angles, we need to round to one decimal place. So that's 51.3.